Now let's move forward with our new chapter, which is enums. And we will see enums and then records. Enums type safe constants. So before Java 5, a fixed set of values was usually represented by a handful of these keywords, public, static, final, int, constants, okay? And that approach had no type safety. And we will see one example that for this int, we can provide any value, right? So no readable to string and debug showed something like this one, not Wednesday. We will see this example, okay? So let's say we have this one. Currently, we are saying the problem that we are about to solve with enums. Create one class, okay, and that can be order status. Here we can have these some constants, okay. We can take our IDE suggestion for now and class order, okay, take those int status. We can make this private to expose one getter function or setter. Okay, and here we can go directly with public void one setter method. Okay, so set status. Okay, now we are good. So this one looks fine, right? And let's create. So our goal here is that our this status can only have these three values. But now, as this variable is now int, then we can set any value. Okay, so we can create here one order, then set status. This one is fine, but we can also set here set status, and rather calling with order status, we can directly call, let's say, 999. This one is fine, okay? If you compile this one, we are good, all right? And you can see here I have created or restored our structure. So I have removed here modules structure, okay, because we don't need that now. So here you can see that we can set triple line here, which is meaningless, okay, in this scenario. And also in debugging, let's say here we have now for only 3 constants, but let's say we have 50 constants, right? Then in debugging, here we can see that pending is for 0 and processing is for 1. But let's say we have 50 constants, then we have to remember everything. And in debugging, where we see these values 0, 1, 2, and 5, then we have to remember and match, okay, with our code that, okay, this one is for 0, okay, and 1 is for processing. So we also have some problems with debugging, okay. How can we set or be more restrictive about these values, right? And to increase some code readability, okay, we can have enums here, right? And we know that enum is one type, so we can remove here this class and we can create, or we can see how we can solve this problem with enums, okay. So let's skip this one and let's back to our enum, okay. Now you can see we don't have to write here public static final int, okay. We can directly go with something, okay, that can be, let's say, pending, and we are not getting any suggestions. Pending, okay. We can go with processing, and let's say completed or cancelled, let's say anything completed, or we can remove this syntax for now. We are good now, okay. So we have created here pending, processing, and completed. And here, instead of doing int, we can write here order status, right? And here we need to take that as well. So order status. Now when we write this one, and this one is valid, but here we will get one error. Required type this one, but we have provided this, okay. So in enums, we only accept our defined values, okay. And in debugging, we will also get these readable names like pending, processing, okay, these kind of things. And now we have full type safety, okay. So basically we cannot use here any wrong value. This is impossible now, okay. So First one, the basics. A simple enum is a list of named constants inside an enum block. Okay, the compiler generates one singleton instance per name. So let's say we have these. Okay, then day today equals to day dot Monday. Okay, then this one prints Monday, not zero. Okay, because today is of type day, right? This one, only one of the seven declared values can ever be assigned to it, and there is no way to pass a something different, right? Okay, where day is expected in your whole code. Int constants, any int is accepted. Okay, no type safety, new enum, right? Okay, now let's move forward with our next thing, which is fields and constructors in our enums. So each enum constant can be initialized with values passed to a constructor. Okay, the constructor is always effectively private so that we cannot create new instances at runtime. Okay, that means we have this private constructor, implicit or explicit, and we know that for private constructors we cannot create instances. Okay, so all instances are created once. That's why we use enums for truly constants, right? By the compiler as the enum is loaded. Okay, so now take a look into this one. Here we have this planet enum, okay, and we have these two constants, okay, and we have these two fields as well, mass and radius. You can add more like Mercury, okay, Venus, Jupiter, whatever you want. And here we have this constructor. Same rule here. Your constructor should have the same name as your enum, okay? And you can initialize these right here, okay? And this one will be always private, implicitly or explicitly, okay? So that we cannot create new instances, only the defined constants exist, okay? Now we have one getter method, okay? This one is surface gravity, okay? Now we can call this method on any constant. Let's say we want this one on Earth, then planet.earth.surface gravity, okay? So we can have unique values for each constant and we will get same value each time, okay? Obviously with same values. Now, from where we will get these values? From here we will get, okay? We have defined here. So why not we just take a look into this one, copy this, remove this public keyword, okay, and we are good. Let's create one more here, anything, Jupiter, okay. We have to put here comma for now, and here we can create, or here we can pass anything. Let's take suggestion, why not? We are good now, okay. So now let's say here, what if we need one more, okay? So double surface, not this one, don't get confused, ABC, okay. Now you will get one error because expected 3 arguments but found 2. So this one should match, okay. If you are providing here values, then in your constructor you must provide same number of arguments, okay. If you comment out that one, then still you will get error because now your these values are final and where you will assign those might not have initialized. That means we have to initialize though, let's say 100, and for that as well, okay. But here we are also getting one error, expected no arguments, because in build we have no arg constructor, right? But here we are providing, that means we have to provide one constructor, okay. So that's how we can do that. Now we can leave these to uninitialized because we will initialize those with our constructor, okay. So these two fields will be initialized with, let's say you are calling this one on Earth instance, okay. Then you will get mass for this one and radius for this one. Okay. I hope you are getting the overall scenario here. All right. We can also have some getter and getter methods for those. So public double mass, return mass, and for getter we can put this one something. Let's say get mass. Okay, get radius. No. Okay, so this one we can do. All right, and we can do same for radius, and we can also provide one more method, that is surface gravity. In this one, final double. Okay, okay, some more calculated thing you can do. Now let's create instance of our planet. Planet, let's say we want planet dot earth instance, right? Now we can call something here surface gravity. We can call get mass, get radius. Okay, so that's how you can use your enums. Okay, now we can run this one. First compile this and then run this. So we are good. I hope you got the point, overall point here. And if you mark this one private, then this one is redundant because implicit this one is private. And if you mark this one public, you will get one error. That is, this one is not allowed here. Okay. Okay, so the data travels with the constant. Any code that has a planet reference has everything it needs to compute physics on it, no external lookup table. Okay. Next one is pre-constant behavior. An enum may declare an abstract method, then have each constant provide its own implementation. This is how the JDK models behavior that differs per value without a cascade of if checks. Okay. So let's say we have this enum and we have here operation enum. Okay. And here we defined one abstract method. Now each constant must provide the implementation for this abstract method. Okay. Without that, you will get one error. And this one is pre-constant behavior we call. Okay. So each constant can have its own behavior. The compiler refuses to compile the enum unless every constant supplies apply. Okay. So adding a fifth operator forces you to consider the new case. All right. Let's copy this one and let's see. Remove this public. And here, this one is okay. And if you write here at override, that's also fine. All right. You can write here something at override. That's still fine. But if you don't do that, that's also fine. Okay. Now, what if we create here one another? So public abstract, okay, and that can be, let's say, int, and let's name this one anything, test. We can take int x, int y, and then that's all. Now we have to provide that. We can do here at override test. So this one is good. And we can do same for each one. Or maybe we just write this one. This one is still okay. All right. So this is how you can add multiple abstract methods as well in your enums. Now we can call these as well here. Why not we just remove this one? Okay, so here we can call or we can create some variables, double, or let's say we go directly. So system, not this one. We want something, let's say add. So for add, we can do something like that. So we have here operation and we are getting one suggestion, operation dot add dot test. That's fine. So in add constant, we have this method, okay, and we are calling this one. All right. Now, can we have simple methods here? Let's check. Public, okay, and maybe just void or test true. We can write something, okay, and it will not do anything. Can we provide here this one, right? So we can do that. Let's call this one as well. Operation.add.test2, okay. So this is how we can define behavior on our enum constants as well, right? Compile this and then run this one. So we got this. All right. But if you define abstract, then your each constant must provide the implementation, okay? And this is just a syntax. Now next one is enums with switch statements. So switch on an enum is the natural fit. With the arrow from Java 14, switch expressions even return a value, right? We know that. We have seen that in our switch statements. So let's say we have this enum, okay, and this one is switch statement, status. So case pending, this one, and all these things, okay. So let's see. We can remove this one for now. Now here, just create one instance, okay, of any constant. Status, you can create for pending, that's fine. And now let's write switch statement for our enum. And we have to handle all these cases, okay, that your order status can provide this one. So we can write here something string, let's say message equals to, and here we can pass this reference, okay, status. Now here we have to define all these cases. So we are getting suggestion. Let's take that one. So first one is pending, okay, is the only reachable in the whole switch. Okay, that's fine. Let's say we are not initializing this one. Now this one might not have been initialized. So somewhere else you have to initialize this, okay, equals to pending, okay. Or maybe let's say this one will depend on some other condition. So you can do that. And here, this one is just warning. And for this case, this one is the only reachable statement we know. But if this one change, then you will get other values as well. Okay. One more important thing is if you add something here, then you have to handle your switch statement. Okay. Like this. Does not cover all possible input values. All right. So you must handle that. This one is another benefit so that you will always tightly coupled with your enum constants. Exhaustiveness. Okay, a switch expression over an enum is checked for exhaustiveness. Miss a case and the compiler complains. Okay, add a new constant and every switch in the code base. Okay, a powerful refactoring guardrail. Okay, so this one is very powerful. Now let's see some built-in methods on every enum. Every enum inherits a handful of methods from our java.lang.enum. Okay, so this one is inbuilt. We know that java.lang package. So let's see with this one array of all constants. Okay, declaration order, then size m, size.value of, okay, medium, lookup by name, exact match, illegal argument exception if absent. All right. Then in position, right, size.large.ordinal. So this one will return your zero-based position in the declaration. So if you declared your constant here, for pending you will get 0. For this one you will get 0, 1, 2, 3, and 4. So like that. Okay. Then we have string enum, size dot small dot name. So you will get here its name. So for small, we have small. Okay. All right. So you can see here the values method returns all constants in declaration order. Okay. And value of string the constant with this name, and you will get illegal argument exception on typo. Okay. So you must match exactly. Now ordinal declaration index, then name, the constants identifier. Okay. Safer than ordinal for persistence. Okay, now EnumSet and EnumMap. For sets and maps keyed by an enum, the JDK provides two specialized, highly efficient collections. EnumSet is backed by a bit vector, okay, and EnumMap by a simple array indexed by ordinal. So both are dramatically faster than hasset and hasmap for the same purpose. Okay, so for that, then EnumSet for permission, EnumSet, and for that, okay, EnumSet.all off for off. Then you can also create your EnumMap. Okay, so these are useful for performance wise. Prefer EnumSet or EnumMap when the keys are enum constants. EnumSet and map are both faster and more memory efficient than their hash based counterparts. Okay, so we can use them by default. Now, implementing interfaces. Enums can implement interfaces, so an enum constant can be passed anywhere that interface is expected. Each constant gets the same method unless it is overridden per constant. So let's say we have this interface, okay, and we know by default all methods in interface are abstract. That means each constant must provide the implementation. Okay, then let's say here this enum implements this one, and we have these three constants. Now private final string description. Okay, we have one constructor. We are providing here value, right? And here we have to provide at override this one string describe. So we must override this one from our interface. And here, if you create instance, then if you call d.describe, okay, so it is returning description, and we are setting description for each constant. All right. So that's all. You can do some code practice on your own. I guess we did. And we have here so many examples. You can take a look into that. Now, common pitfalls. Do not persist ordinal. A teammate reordering the constants, silently changing the meaning of every stored value. Okay, so persist, name a string or a dedicated ID field instead. Value of throws on unknown input. If the input comes from the outside world, okay, tap the call in a try catch, right? Then enums are singletons. Serializing an enum and deserializing it still returns the same instance. You can use to compare enum constants safely. And we will see serializing and deserializing also in our this series. Okay, now let's move to our next type, which is records.